Number 30, determine algebraically the zeros of f of x equals 3x cubed plus 21x squared plus 36x. So when we determine algebraically the zeros of a function, what we're going to have to do is cross off that f of x and make it a zero. You want to set that equation equal to zero. So now we've got 3x cubed plus 21x squared plus 36x equals 0. This x cubed right here should be a little hint to you. Have we factored x cubed trinomials in class? No, not really. And if we did, we had to pull out a greatest common factor first. This leading coefficient of 3 should have been your second hint that we are going to look for a GCF first before we try to factor this guy. So let's go ahead and try to identify the greatest common factor between 3x cubed, 21x squared, and 36x. Well, in order to make a 3, I would just have a 3, right? And then to make an x cubed, I would have x times x times x. To make a 21, I've got 7 times 3. To make an x squared, I have x times x. To make a 36, I've got 3 times 12. And then the x is just over here. So what are the things that they all have in common? They've got a 3, and they've got an x. Therefore, our GCF that we're pulling out of each term is going to be a 3x. So he's going to go outside of the parentheses. In order to get the terms inside of the parentheses, I'm going to have to divide each piece of the trinomial by the GCF. And that's going to get me the pieces inside the parentheses. 3 divided by 3 cancels. X cubed divided by x gives me x squared. 21 divided by 3 gives me 7. X squared divided by x gives me x. 36 divided by 3 gives me 12. X divided by x cancels to 1. Okay, so now, I wanted to stick with the black there. I had like a theme. Okay. So now I have a GCF out front, and then I have a trinomial in parentheses. Let's see if that trinomial is factorable, because that would be the easiest way to get this guy into a form where we can solve. So I'm trying to think in my head now. What are the factors of 12 that add up to 7? Factors of 12 that add up to 7. Factors of 12 that add up to 7. Factors of 12 that add up to 7. Oh, 3 and 4. Excellent. So if this is a positive 12 and the middle term is a positive 7, I'm going to make both of these positive. And now I'm just going to double check if I'm right. Does 3x plus 4x equal 7x? It sure does. Fantastic. I have my two factors. So I've got 3x times x plus 4 times x plus 3, still set equal to 0. Now I'm going to go ahead and make my t-chart so I can use the zero product rule to get my solutions. I'm going to set each factor equal to 0 so that way I can solve for x in each of the 3 scenarios. So in the first one, I have 3x equals 0. I'm going to divide both sides by 3 to get x alone. The first solution is x equals 0. In the second factor, I'm going to subtract a 4 from both sides, and I have x equals negative 4. And then in the third factor, I'm going to subtract a 3 from both sides, and I will get x is equal to negative 3. So I have 3 solutions, or 3 zeros. Ooh. And if you want to get fancy, this is totally acceptable. If you want to get fancy, though, you could list them in ascending order in curly brackets.